Good morning, everybody. I'm going to be out for a while, so I'm going to be posting a video daily when you have some assignments, and hopefully, we won't get any further behind than we already are due to hybrid. So, that being said, I need you to take some responsibility so that you don't get behind. You need to make sure that you come to class every day on campus with earbuds and pencil and paper, and be prepared to watch uh, a video that might be 20, 30 minutes long, and then spend the rest of the class time working some problems out and doing assignments based on the video. So the video will just take the place of me standing in front of you talking every day. I will be checking my email daily. So hopefully my goal is to try to be pretty near my computer and have my email up and open all day. So if you have questions as you're working through a problem, you can send me a screenshot. You can put a private comment on the Google Classroom assignment, or you can send me a screenshot and shoot me an email, and hopefully I'll respond fairly quickly. I will be checking towards the end of every class period to make sure that you actually did your assignment. So, for my B group that was there on Friday when I had a sub, I've already gone through and checked each of your assignments, and I returned those graded to you. So basically, you're going to get classwork grades for completing and correctly following instructions, not necessarily getting correct answers, but correctly following instructions. So, for example, if I post a Google Slides assignment, you need to read all directions on every slide. Okay. All right, so let's get started with today's assignment. So this is either a Monday or a Thursday for you guys. So whatever day it is, Monday or Thursday, I'm going to use the same video for both groups. You're going to click the assignment with today's date, and you're going to look at those directions. Okay, so today's assignment says complete digital interactive notebook pages 3, 4, 5, and 6. So the first thing you're going to do is go to the left-hand side of your stream. So, not stream, I'm sorry. You're going to click the classwork tab, and then you're going to go to your digital interactive notebook. And you're looking for a new notebook that I've shared that's Unit 4, Linear Relationships, and you want to open that one up. It's going to be a bright blue cover, and it is brand new. Okay. I've already put a table of contents in there for you with links to every page, but the directions today are to complete slides 3, 4, 5, and 6. That's a lot. So I'm going to walk you through each of this. Okay. And I'm just like I would do if I were in class, I'm going to do this right now. Okay. All right, so if you're still opening that up, you might want to hit the pause button on your video, but I'm going to keep going. Okay, so if you need to pause it till you get it open, go ahead. All right, what we're going to talk about today is actually a review from 7th grade. I know that this is something your 7th grade teacher should have spent a good deal of time on, and that is slope. Okay, so we're about to get into graphing relationships and graphing lines on a coordinate plane. And the first thing that we have to understand is slope. Okay, so what is slope? Slope is the rate of change in a relationship between two values. Okay, on a graph, slope represents the steepness of a line. So how high it climbs or how far it falls. Okay. There are 4 different types of slope that we're going to look at today. And you're going to do an activity in a few minutes using these 4 different types of slope. Whenever you're talking about the type of slope, I want you to look at the graph from left to right. Okay. So for example, this graph from left to right. If I start at the left-hand side of the graph and travel to the right-hand side, that line is going up. So that is a positive slope. A positive slope shows an increase from left to right. So the opposite of that would be a negative slope. And it's going to decrease or go down from left to right. Then you have a horizontal line. So it goes from side to side. A horizontal line is what you're going to call a zero slope because it doesn't go up, it doesn't go down, it just goes side to side. Then we have a vertical line, so straight up and down. This is what we call an undefined slope. Okay, so make sure you know the difference in the way a zero slope and an undefined slope look on a graph. Zero is left to right, undefined doesn't go up or down, it's just straight vertically. Okay, now go on to slide 4 and we're going to talk about how to find slope. Okay, so you can be given a graph, you can be given a table, or you can be given a set of ordered pairs. And there's several different ways to find slope or find that rate of change based on tables, graphs, charts, ordered pairs. Okay, so I want you to look. There's a lot of information on this slide and it can be very overwhelming, but what you see on the left, this triangle y over triangle x, this is our slope formula. And I think I'm going to add something right here that points out that that's called the slope formula. So let me push the pause button. Okay. I decided to add a little bubble here. So that'll tell you that this is the slope formula. You can write a slope formula 2 different ways. You can write it with a triangle over y over a triangle x. That triangle actually means change in. Okay, so change in y over the change in x. And what we've done is we've created a ratio to show the relationship between how y changes and how x changes. Okay, your x is your independent variable, and your y is your dependent variable. You're going to hear about that in science too. Okay, so what happens to y is dependent on the value of x. Okay. So change in those little triangles simply mean the difference of. And we talked about the word difference recently. The word difference means to subtract. Okay. So basically you're finding how much, what the value, the distance between the 2 y values are and the distance between the 2 x values. And there's several different ways to look at that. So we're going to look at that using a table of values, and then we're going to look at that using an ordered pair. So I want to just look at the top half of this slide for a second and just this table. Now you're also going to see this letter M. So don't let that, confuse you in any way. M is the variable we use to represent slope. So anytime you see that M over the next few weeks, know that we are talking about slope. Okay. All right. So we're going to find the distance or the difference between each of these values in the X table. So how far apart are 0 and 1? Well, if I'm counting or I subtract 1 minus 0, I'm going to get 1. Okay. What's the difference between 1 and 2? Well, that's also 1. And the difference between 2 and 3? That's also 1. Slope is consistent. So the difference between these two numbers should be the same as the difference between these two numbers. Okay. All right. Now let's check this. What's the difference between 5 and 5.5? The difference between 5 and 5.5 is 0.5. 0.5 and 0.5. Okay. All right. So when we write this as a ratio, we're going to write the change in y. So in your table, your y's were represented by your bottom row. So that difference was 0.5 over the change in x was 1. Okay. Now let's try this one. Now here's the thing about slope. This really isn't typically how we would write a fraction. Okay. So you can leave it this way, that's fine, or you can simplify it. If I reduce that, anything over 1 is going to be the same as its top value. So it's just going to be 0.5, okay? All right, now let's look at this table. When you have a table of values written this way, typically your X value is on the left and your Y value is on the right. So let's go over here to the left and let's look at the difference between each row. So how far is it from 1 to 3? So how much would I add to get from 1 to 3? And I'm going to add 2. And then I'm going to look at the next row. How do I get from 3 to 5? Well, 3 plus 2 is 5. And how do I get from 5 to 7? 5 plus 2 is 7. So these are my X values. So my X is going to be, my change in X is 2. Now look at the right side. What's the difference between each of these? Now these are larger numbers. Is it okay to use the calculator? Yes, you are subtracting. So we're going to talk about the difference. So how far is it? Now, are these numbers on my X column, they're going up, right? 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 7, or 5 plus 2 is 7. These are going down. So when you have values that go down, how do you show it's going down? With a negative sign, okay? So how far down? 360 minus what is 240? 120. 360 minus 120. I need to make these boxes bigger for you. All right, so how much is between 240 and 120? Again, we're going to subtract 120. And then again, we're going to subtract 120. So we now have a change in Y that is negative because that value is going down. So negative 120 over 2. Now, you do want to reduce any fractions that you can. Okay, you do want to reduce any fraction that you can. So you can either put this in your calculator or some of you may just know it, but we're going to go ahead and simplify negative 120 over 2. So that's just simply dividing negative 120 by 2. Now, a negative divided by a positive is going to be a negative, and 120 divided by 2 is 60. So this time we're going to have a negative slope, okay? And I'm going to hop back to this one for a second. I added another box for you so you could go back and reduce that. Anything over 1 is the same as its top number. So I'm just going to take the top number and type it in that box. Now, keep in mind when you have a decimal value, you can type the 0 in front, but you don't have to, okay? You can, doesn't change the value. All right, so just looking at this, we have one slope that's positive and one slope that's negative. So what I want to do is flip back to slide 3 for just a second and think about that. So those are our slopes. We have a positive slope and a negative slope. That means if I graphed these two lines, the first one, the positive 1/2, would climb from left to right. It would show an increasing. It would look like this. The negative 60 would look like this. It would go downward. Now, this number describes the steepness. So the steepness means how sharp of a climb or how sharp of a fall. This positive 1/2, it's not going to be a very steep line. The smaller the number, the less steep it is. The larger the number, the greater the steepness. So negative 60 would be a fairly steep line. All right, let's go to the bottom half. Now, this time, instead of being able to look at a table of values where you can easily see the difference between two numbers, you're given an ordered pair, okay? Now, one thing I want you to remember And I'm going to swap over to this view for a second. Well, one thing I want you to remember is when you're given an ordered pair is an X value and a Y value, okay? So you've got to look at this ordered pair and remember which number represents your X and which number represents your Y. Remember that the first number in an ordered pair is always your X, okay? So I'm going to label these for you real quick. Okay, so I added some labels to your slide for you, and there's a couple of things that I need to point out. First of all, you have to remember that X is always the first value in an ordered pair, and Y is always the second value in an ordered pair. Okay. Now, when you look at this version of the slope formula, it actually means the exact same thing as this. It means the change in Y over the change in X. Again, we're creating a ratio that just shows the distance between Y and the distance between X. Now, this is written a little bit differently. Instead of simply saying change in, we actually have some mathematical steps. So we have Y2 minus Y1 over X2 minus X1. Now, let me explain those twos and those ones. That doesn't mean to do any operation. That simply means you're taking your second Y value and subtracting your first Y value. Then you're creating a ratio or dividing that by your second X value minus your first X value. So I went ahead and labeled these for you, but as you do these on your own, the best thing to do is write each one down and label it as you go. All right, so let's start. Our second Y value, or our Y2, when I look at these ordered pairs, is 7. And then our, as I'm recording this, I'm finding little things that I should go back and add in to help you guys out. All right, so what I did was I went and labeled these boxes for you to kind of help you with which value to put in. So again, when you do your work in a minute on your own, you're going to have to take the time to label those. So I really hope you're paying attention to this. All right, so I'm going to take that Y2, which is 7. So again, that 2 doesn't mean to do anything. We're not multiplying by 2. We're just looking for the second Y value and writing it down. All right. So Y2 is 7. Y1 is 4. Then I'm looking for X2. So I'm going to go over here. Here's my X2. That is a 1. And X1 is a 2. So now we're just going to subtract. We're going to do exactly what this problem says to do. So I'm forgetting all this and I'm just focused on this. So 7 minus 4 is 3. And then we have 1 minus 2. I'm taking away more than I have, so that's going to give me a negative number. So that's -1. Now, when we have a ratio that has a negative value in it somewhere, we are dividing by a negative. So a positive divided by a negative is a negative. And anything divided by 1 is itself. So our slope for this line would be -3. Now, we have whole numbers for each of these 3 answers on this slide. That's not always the case. Sometimes we're going to have fractions. Sometimes we're going to have decimals. Sometimes we're going to have whole numbers. It's going to be a little bit of everything. And that's okay because slope means something. And especially when it's written as a fraction. A lot of times I like to leave my slope as a fraction. So even this -3, I might leave 3 over -1. Because if you'll go to the next slide, slope tells us a rate of change and it tells us how to look at it on a graph, okay? So slope is represented as a ratio of the change in Y values to the change in X values. So slope can be thought of 3 different ways, and we've already looked at these 2 ways, okay? Which is the change. So I'm going to save this one for last, okay? But we've already looked at it with these triangles, and remember that those triangles mean change in, and the Y goes on top. So the change in the Y over the change in the X value, okay? It's great to think of it this way when you're looking at a table of values. So if I go back to slide 4, if you're given a table of values, this is the best way to think about slope, change in y over change in x, because you're just looking at how these numbers are different, okay? Then you have the slope formula here, which is y2 minus y1 over x2 minus x1. This is something you probably want to memorize, but this is best to use when you're given two ordered pairs, like in this, okay? Then we can also simply think of it as the ratio on a graph as the rise over the run, okay? Rise over run. And I drew some arrows there because this rise talks about how the graph goes up or down, okay? So we could say rise or fall. And then run would be how it moves left or right, okay? So you're going to have a negative slope if your line falls, if it goes down. And that, if you think about that, that kind of makes sense, right? If you decrease, that's negative, okay? So now let's look at our slide 6 real quick, and we're going to look at how to count this on a graph and what that looks like on a graph. So slide 6. When you find slope on a graph, it's actually, to me, this is the easiest way to find slope, okay? You're looking for the rise over the run. And this, I know Miss Kennedy went over this with you guys a lot last year, okay? So the steps to find slope on the graph are the rise of the graph. So you're finding 2 points on this graph, and you're going to count, and you're drawing a triangle, okay? You're thinking about, if I make a right triangle and I go straight up and straight over from one point to another, how far am I going? So if I count from here to here, how far is that going to be? Now, when I say count, you do have to pay attention to your intervals. In this particular example, we're counting up by ones, so we're okay. But sometimes you're going to count up by 2s or 3s or 50s or hundreds. So not every line represents 1. In this case, it does. Okay. All right. So how far up? If I start here, don't count where you start, count the moves you make. 1, 2, 3, 4. So we have a rise of 4. It's climbing up, so that's positive. And then the run, we're always looking left to right. So when you're counting on a graph, your run is always going to be the positive number. The rise, if you're counting down, might be negative. But the run, you're always going left to right. So again, don't count where you start, just count the moves you make. 1, 2, 3. So you have a run of 3, a rise of 4, and a run of 3. So if I make this a ratio, I'm going to have 4 over 3, and you can just use the slash button this time. So that's going to be your fraction, 4/3. And that doesn't simplify. You can change it to a decimal if you want. If this were a test question, I would accept 4/3. I would leave it 4/3 if it were me. Or you can have 1 1/3. Or you can have 1.333 with a line over it. You can't type, so it's going to just be dot, dot, dot. But that 3 would go on and on forever. So that's 1 1/3. All right. So that is your interactive notebook pages for today. That's a lot of information for one day. But that's okay. It all kind of goes together, and unfortunately, we're having to move fast, and I'm not there. So we're just going to do the best that we can. Again, if you start doing this work in a second and you've got questions, shoot me an email. I'll respond as soon as I can. All right. So now we're going to look at the worksheets for today. So you're going to go back to your Google Classroom, and yours will probably be the first thing in your stream, but mine's going to be a little different because I haven't shared anything. It's 6:30 on Monday morning, so mine's going to look different than yours. But I want you to look for the assignment for today, whether you're a Monday or a Thursday group, and you're looking for the PDF called Slope and Rate of Change. Okay, Slope and Rate of Change. So go ahead and get that open. All right, so when you get that open, it should look like this. And if you notice, your directions say do the evens only. And I have 3 pages of work for you, okay? But if you do the evens only, that's only going to be about 10 problems, okay? All right, so evens only. We're going to work a couple from each section together. And then so you can work these in the correct order. You don't have to bounce around like we do in class. That's the good thing about a video. So as I'm doing the problems, you can pause the video and finish that section before you move on to the next section. Okay. All right. Whoops. Okay. All right. So part 1 says that we are going to match each blank with the correct vocabulary term at the right. So number 2, because we're only doing the evens. The horizontal change on a graph, let's zoom in a little bit, is described as horizontal. Horizontal means that we're going left to right. Would that be your rise or your run? Left to right. That's going to be C, your run. Okay? So I'm going to leave you to do 4 and 6 in this section. All right, now we're going to go down here and we're going to look at this graph of the word math, okay? Each of the line segments in the word math are numbered. You're going to find the slope. You're going to find the ratio of the rise over run for each line segment. So let's look at number 8 together. That's going to be line 2. So that means I'm looking from here to here, just this portion, okay? So remember that when you are finding the slope on a graph, you're thinking of it like a triangle. So I'm going to swap pen colors for a second. And we're thinking of it from left to right. So remember that I'm looking for the rise over the run. So that means I want to make a triangle that goes from this dot to this one. Now, that line is going down. So if that line is going down, it's going to be a negative value. So I'm just going to go ahead and put that negative sign there before I forget about it. And I want to know how far down am I going? Well, let's count the spaces we move. 1, 2, 3, 4. So I have gone down 4. And how far over from left to right? 1, 2, 3. So I've gone over 3. So down 4 over 3. So that's negative 4/3. Okay? Negative 4/3. Now, I forgot to mention this when we started the first couple of problems. Do this using your PDF viewer, okay, or your PDF, whatever it's called. Use your Read and Write PDF editor and send this to me that way so that I can see your work. If you try to do this on notebook paper, you would have to draw all of these out. So I want you to complete the work digitally, okay? Complete the work digitally so I can check it today. All right, let's go ahead and do number 10 together as well. So I'm going to circle 10, and that's line 4. That's this one. All right, think back to your notes for a second. This is a straight line up and down, okay? That is a straight line up and down. So I want to go back over to our interactive notebook, and I'm going to go back to this first slide that we looked at together today. Vertical line. A vertical line is undefined. So as you're doing your work, leave your interactive notebook open in another tab so you can go back to it. Because if this is your first time seeing this, you may not remember that a vertical line is undefined. Okay? So you're going to continue working and you're going to look at line 6. I'm going to highlight the ones that you're going to do. You're going to do line 6. Number 14 is line 8. Number 16 is line 10. And number 18 is line 12. So you're going to do those 4 additional lines, and then you can move on to the next section. All right. Slope and similar triangles. So now you're looking at the triangles. So on this section, you're going to do number 2. So let's look at this one together. Catherine used the points and the right triangle shown to find the slope of this line. Catherine found the slope to be 1/10. Is she correct? So she says 1/10. So we're going to count the rise over the run. So how far up does this line go? 1, 2, 3, right? Does that climb 3? Did anybody notice this? So does that line actually climb 3? No, it doesn't. We're counting by tens. So if I've increased by 10 each time, I've actually increased by 10, 20, 30. I was seeing if you were paying attention there. So we have an increase of 30. So that's a rise of 30. And now let's count our runs. So let's look at our intervals. Those are ones this time. So 1, 2, 3. All right, so we have 30 over 3, and Catherine says 1/10. So what I want to know is, does 30 over 3 equal 1/10? Does that? No, she is incorrect. If we simplify that, that's going to be 10 over 1. So the slope is actually 10. She counted it backwards. She wrote her x value, her difference in x, over her difference in y, instead of the difference in y over the difference in x. All right, so this particular page, we're not going to worry about. We're going to skip number 4. Actually, we're going to skip the rest of that page. I should have left that page off entirely, but that first question was good. So if you're watching the video and paying attention, you will realize really quickly that you don't have to do that whole page. All right. Slope formula. So this is where you're going to have your either a change in y over change in x, or y2 minus y1 over x2 minus x1. Now, whichever one you use, I want to see it written out, okay? So a line has a slope of 5/3. Which of the following could pass through that line? So you're looking for a difference of 5/3. So that means on your paper, this I would write down on notebook paper, okay? And then just circle the right answer. So what you're going to do is you're going to have to take this formula for each of these. So this is your x1, this is your y1, this is your x2, this is your y2. And let's plug it in. And that's going to be the same all the way down, okay? So let's plug in each one. So this is A, and we're going to say y2 is 4 minus 13 over x2 is 0 minus 15. Well, I'm looking for 5/3, which is positive. And when I look at this, right away I notice, well, both of these are going to be negatives. So let's keep going. All right, so this is going to be -9 over -15. Will that reduce to 5/3? No. If I divide them both by 3, it's going to reduce to 3/5. So that's not going to work. All right, let's look at B. I'm going to zoom in a little bit more. So B, I'm going to have y2 is 14, y1 is 9, x2 is 6, x1 is 3. 14 minus 9 is 5, and 6 minus 3 is 3. So that gives me 5/3. So the correct answer for this one is going to be B. All right, we're going to continue going down. All right, so you're going to try to complete 4, 6, and 8. Okay. And on all 4 of these, or 3 of these, you're going to use y2 minus y1 over x2 minus x1. And what I want you to do is I want you to use a sheet of notebook paper to write everything out. And then I want you to use the PDF editor tool, PDF reader, whatever it's called, read and write, and write your answers on this document and return it to me. Okay. All right. So I'm going to help you out with these 2 at the bottom. And I'm going to label these for you. This is X1. This is Y1. This is X2. This is Y2. X1, Y1, X2, Y2. So you're going to use that formula, Y2 minus Y1 over X2 minus X1 every time. I'm going to go ahead and plug the numbers in on number 6 for you, and you're going to do number 8 on your own. So on number 6, Y2 is 8, Y1 is 8. So 8 minus 8. Then, I'm going to swap pen colors. X2, negative 5, X1 minus 10. Now, I do want to point something out about number 8. On number 8, y2 minus y1 over x2 minus x1. When you write out number 8, you're going to start with 2, and you're going to subtract negative 7. So you are subtracting a negative. You are subtracting a negative. Do not forget what that means to do with your signs. Remember that actually changes to a positive if you're doing it on your own on your paper, or if you're using a calculator. If you'll punch it in, your calculator will do that for you. Uh-oh. Not sure how that happened. Guess I slid all the way up to the top. Oh my goodness. See, I still have technology issues at home too. All right, so I'll go ahead and fill this one in, even though I said you could do it on your own. All right, so 2 minus 18. All right, if you can get yourself to that point every time, all you have to do is put it in the calculator from there, okay? All right, so that is your assignment for your first day on campus this week. So if you're a Monday group or a Thursday group, this is your assignment for Monday or Thursday, okay? Remember, as you're working this out, if you have any questions, any problems, you need help with something, Miss Franny is your sub today, and she is more than capable of helping you with slope. I'm sure she remembers how to do slope. Also, you can email me. You can take a screenshot of your work and email it to me, whatever you need to do to get you the help you need to get through this today, okay? And I will hopefully see you guys next week. I'll post another video tomorrow. And then your hybrid work for the 2 days that you're out, so either Thursday and Friday or Monday and Tuesday, will be slope stuff, more slope practice. And I'll probably post another video just to kind of get you started on that. All right. Thanks, guys. Please do your work and submit it digitally for me. I'll be checking it at the end of the class period. Thanks.